I'm head of Ericsson's Group Technology Strategies based in Silicon Valley. I was intending to focus, so this is a little bit of a jump start of tomorrow's session where we will go into more technical details in many areas. So I will focus more on the SDN piece, the virtualization of the applications or functions in the network, and how that relates to cloud. But if you have other questions in the network or elsewhere, I'm happy to discuss that as well. I will also mention something we term network slices. Network slices as a way to build networks for all these new industries that we heard about today. How can we build networks that work for media companies? How can we build networks that work for the car industry? How can we build networks that at the same time work for mobile broadband health applications? All of these requirements can then be realized in networks by something we call network slices. So let's start with the basics, and that is the trends that we're building this on, which is mobility. It's very much about cloud and broadband, and it's also about need for new regulation and how the industry is coping with these changes. So I will, of course, focus more on the mid part here, the cloud piece and the broadband piece, the IP piece. But I have to start on the mobility piece, because everything that we are seeing now is so linked to what's happening on the mobile side. Clouds will basically be useless in the future without the strong mobility piece. So mobility and cloud goes together. Now what did Ulf talk about when he said that the networks are built for voice and not for data? Well, it was basically this fact that between two antennas, between two base stations, there is a certain distance. You have a certain grid in a city like Tokyo, which was made up in order to guarantee good voice quality wherever you are here. But as we all experience, in the age of data with megabit per second speeds, we don't always get 10 megabit per second, or 40 megabit per second for that matter. There are places where we are indoor or between base stations where you will only get your voice calls through or your text messages. And this type of very dynamic network behavior is something that the applications need to adapt to, but it's also something that we need to address with in-building solutions like the DOT and coverage solutions. You also know that LTE is very much picking up speed from 10% roughly population coverage end of last year to around 60% population coverage by 2018. So very, very strong uptake in LTE, focused in Japan here, Korea and USA mainly. When we talk about mobility, all these aspects are on the agenda, I would say. New spectrum, which was one of the questions at the end of last session. How can we get more spectrum? How do we get continuous spectrum, 100 megahertz? How do we allocate spectrum in smaller chunks and can aggregate it? And we have a target that by 2020 we need around another gigahertz of spectrum, at least. So there is a big movement to reallocate spectrum and allocate new spectrum for mobile services. It is very much about technology, how to build it and the topology, how to build small cells and how to build macro sites. And it's very much about converging solutions that cover all kinds of cells, the small to the bigger one in one network architecture, to get capacity coverage and all for the user experience that we would like to have across the network. So this is a very, very strong driver. 5G then, by 2020, we don't see any reason that we would have 5G systems before 2020. But in this time frame, we're looking at drastically different requirements on the networks in terms of latency, in terms of speeds, and also in terms of the architecture, moving more functions further and further out in the network. So this is seen as an introduction to what happens in the rest of the network. Another very big trend or a very big requirement on these future networks is to make them more video optimized, media aware. And you are aware, I believe, of Ericsson's expansion into the TV space with the acquisition of Microsoft Media Room, for example, and what we are doing in proxies in the networks to optimize video delivery as well as CDNs or MDNs across the network. Can you get a chair? Yes. Here's one. Here's one. Or two chairs, actually. There is one more here. Today's network, they have media delivery functions and caches bolted on afterwards. That is how the current networks are built. In the future, media delivery will be an integrated part in all the networks. It will be there to give good quality independent of whether you are connecting on a smartphone, a big screen TV, a tablet, or any other device. So this is an integral part of future networks, the proxies and the caches. And it covers everything from classical internet video to high quality, premium value managed content, even to industrial video applications served by one and the same infrastructure. And this is new. This is nothing that we've done before. We have delivered and built point solution in the industry. Now we will have it in the future as a foundation inside all the networks. So you can see those big trends, the mobility trends, the video trend as strong technology-focused drivers onto the rest of the network. But the network, of course, consists of more than a mobility piece. It consists of a fixed IP piece, and it consists of a data center piece or a cloud piece. So now I will talk much more about what's happening in the fixed IP piece and in the data centers or in the clouds. So, small gallop here. How many are familiar with software-defined networks, SDN? Half. Then I will talk a little bit about what SDN is, and then I will dive into why SDN, as it's originally designed, is not good enough for the future networks. So software-defined networks came about initially as research, as most of these technology trends, to solve the problem of how to build network infrastructure inside a data center. How do you connect all the servers and the storage and everything that you have in a data center? The current networking technology for data center is not good enough. It's too costly with the current routers and switches, and it's not flexible enough to connect all these virtual machines that are sitting in the data center. So that was the idea. How can we get away from static switches and routers inside data centers? The solution to that was to break up the routers and the switches into a forwarding part, which transports all the bits, and the brain part, the control piece that decides where the bits should go. So just split the switches and the routers into two parts. Something that decides where the bits should go, and something that simply delivers the bits according to the rules. Now what we have done is to take this basic concept of a router that does forwarding separate from the brain part, separate from the control part. That is SDN in itself. About 2 years ago, we started to see that this technology can actually change the way we build also mobile networks. It can change the way we build enterprise networks and fixed IP networks. Because you have the same challenges. Those fixed IP networks and the enterprise networks, they are built on an old architecture. They are built on an old paradigm of building monolithic boxes, routers that do everything in one box. while for the long-term future, we need more flexibility. And that flexibility comes with this service provider SDN, where we add control across the whole network, from the base stations out in the field, all the way through the network, all the way up to the data centers and clouds. We do the same for the management, network and cloud management. And we do it for something we call service awareness, to link the networks with the Facebooks, the games that you heard about earlier. Anyone who wants to reach into the network to optimize the user experience. So those were things that Ericsson added about 1.5 years ago. And we worked with leading operators around the world in order to show the concept, to do trials with customers like Telstra in Australia and others around the world. And it was proven that this is actually a good way to build also future fixed IP networks. It is a journey, it doesn't happen overnight, but it is a journey that is worthwhile exploring. So this is 1.5 years ago, and this is basically showing you that now we are commercializing this. Now it's becoming real in the networks. Now we can show that this technology can be built into commercial networks and provide value, for example, for use cases such as service chaining, which is a way to save network resources and utilize the network infrastructure in a much more flexible way than today. It has also shown the industry that the future networks will actually be more open. They will be more horizontal. We will have more of independent layers in the network because we want faster service innovation. And it has also shown the way towards more efficient enterprise and SMB networking. And I will show an example of how you can make the connectivity for enterprise and SMBs much more efficient. So this is a year of proof points that Ericsson and the industry at large is moving ahead with this new technology, which initially, as I said, started out as a separation of the control and the logic in the router, to look at the whole network as a programmable platform where you can set up network connections much faster, with much more reliability, and to meet unique needs. Every smartphone, every user, every sensor, every media stream can have its unique connectivity through the network. That is the flexibility that this technology allows us to do. You do not have to spend 30 days in negotiating SLAs and contracts. You do not have to have thousands or at least hundreds of engineers doing programming directly on the routers for setting up networks. You can do this with automation, programmatic. You can do it on a click of a button, and then the network gets configured. This is what this is showing. Will it happen overnight across the networks? Absolutely not. This is a big change in terms of how the networks are built. This is something that takes years in most cases. But the first steps are taken. And from Ericsson's point of view, we are leading this when it comes to applying this technology to the wide area networks, the fixed and the mobile networks across the world. And from a technology path, from a technology point of view, this is shown to work. There are still outstanding issues that we as an industry are working on. But now the challenges are moved over more to the business side, business models, and also the operation side. One way to look at that is that we started out with the technology. And here you have the contribution to sleepless nights, basically how difficult it is to fix a problem. And we are well on the way in terms of going through all the technology challenges with this technology. But we, of course, have much more to do when it comes to the business side of this and the operation side. So that's the basics of what SDN is in terms of the technology and how we can apply it in the networks to provide a growth opportunity for operators because they can address new customers, they can address new segments that they couldn't address before. At the same time, they can get savings in CapEx, but in many cases more in OpEx, because this is about automation. This is about self-provisioning and providing all the tools for setting this up in a flexible and dynamic way. No manual intervention, no command line interface hackers to set up a service, set up a network. Is this the only technology that we need in the future? No, it's not. And why is that? And that's because in a data center, you can change out pretty much most of it, and it works as a data center. A network doesn't work like that. A network has domains, a network has interoperability, a network has interfaces that you still have to comply with. So we need to start in some regions, some domains, when we implement this in the network. And by that, we can ensure stability and robustness of the networks as we move into this new technology. But it is an important change because it allows us to free up resources to make the networks more usable by these other industries that you heard about today. Now, cloud on one hand and SDN on the other hand. What is the relation, and why do we talk about SDN and cloud as two different things? Aren't they just the same thing? One way to look at this is to say that on the network data center side, we can use virtualization technologies to gain CapEx and OpEx and efficiency in terms of how we implement the functions. Everything in the network that we over time will implement on a common platform, a virtualized platform which allows us to run all the applications in the same environment. That's a good thing. And it's driven out of the trend that network functions can be virtualized. It has been shown in the IT industry, but now we have to adopt it to networks. And this is what the industry is working on as something we call network function virtualization, the NFV. Many operators around the world are engaging in NFV as a way to move their applications into a common virtualized environment. The other trend is really that the mobile networks, they are relatively flexible and easy to program. When you make a web browsing session, or you make a call or a video call or something else, you are instantaneously programming the network. You're setting up sessions based on your preferences as you want them. You don't have to negotiate with the operator now about setting up a new contract to do that. This is all happening on the fly. That type of flexibility does not exist in the enterprise world, nor does it exist in the fixed IP world. But with the use of this SDN technology, the service provider SDN technologies, we can bring some of those good characteristics of the mobile side, the mobility, the mobile infrastructure, all the way into the fixed IP networks, all the way to the data center. So as this other arrow suggests, let's make the IP networks modern. Let's make them more dynamic and flexible, in a way more like mobile networks. So these two trends, fundamental trends, which are basically mobility on one hand and cloud on the other hand, they help the operators to rebuild their fixed network infrastructure, their core networks, into more horizontal network, easier to program, and more flexible to take on new services, at the same time as there are savings in OpEx and CapEx. When we put this together, and now it gets a little bit more technical, a little more technical. If we put all these things together, then here you have the data centers, further out you have the network, the IP routers and the edges, and even further out you have all the radio base stations, the Wi-Fi access points, the radio dots that you saw in the earlier session, everything that is providing mobility and access. So this is a complete network. If we provide this common virtualization environment across the whole network. Then with a click of a button, we can say that something that is a game, that is extremely delay sensitive, that needs to have certain resources in terms of memory and compute, can dynamically be moved from this central cloud, central data center, further out in the network, because that application demands it. So this is a flexibility that we're introducing. We can move these applications across the network, not only between data centers, but we can move them out into the infrastructure. This is what we call a network-enabled cloud. Then there's some more details about how we build this in terms of controllers and orchestration. You have to connect all these things together, and then of course you have to expose it to that car industry that wants to have low latency for their safe driving and the self-driving cars in the future, the healthcare, the utilities, the media companies, and all of that. With this way of building the networks, we get more uniformity. We can provide these network services in an easier way to all these other industries. So, now is a question. Should we go into a few examples, perhaps, of what is happening with operators? I think we could do that. I'm not trying to go deeper down now, but if you have questions or thoughts on what I've presented so far, that's, of course, a good time to have a checkpoint here.